Okay, so today we're going to talk about the exponent rule. So we start out and you see this scary purple problem at the top. But it's not going to be so scary once you learn these 7 rules. So if you apply these 7 rules to just about any exponent problem, you should be able to break it down and solve it and simplify it. Okay, so for example, there are 7 rules. The first one is the zero exponent rule. We have the negative exponent rule. The rules that apply to quotients, the quotient of powers, the powers of a quotient. And then we have these 3 that apply to multiplication. So we have the product of powers, we have the powers of products, and then last we have the power of a power. So we're going to learn about these 7 rules. So first of all, let's talk about the zero exponent. So anything raised to the 0 power is 1. So that's pretty easy. Let's talk for a moment about why that works. So we know that 3 squared is 9. We know that 3 to the first is 3. So each time we have 1 less 3. So we have 9 divided by 3 is 3, and 3 divided by 3 is 1. So if we follow the pattern, it makes sense that 3 squared is 9, 3 to the first is 3, and 3 to the 0 would be 1. So some other examples, A, B, C, all of that raised to the 0, still 1. A to the 0, still 1. Anything raised to the 0 power will always be 1. Next is the negative exponent. So the rule for negative exponent is that you're going to change any numbers or variables with negative exponents into their reciprocal. So for example, if I have 3 to the first, we know that's 3. Then when I go 3 to the 0, we just learned that's 1. So if we follow that pattern, 3 to the negative first becomes 1/3. You can see each time we decrease in a power, we divide by 3. So 3 divided by 3 is 1. 1 divided by 3 is 1/3. So here's why this works. An example would be 5 to the negative second power. That becomes 1 over 5 squared. And we can further simplify that to 1/25. Another example with a variable, x to the negative fifth becomes 1 over x to the fifth. Okay, so you can see with a zero exponent, everything turns to 1. With a negative exponent, you turn it into its reciprocal. Okay, so for rule number 3 and 4, these are the quotient rules. So number 3 is the quotient of powers rule. So for example, if I had a to the m over a to the n, I would then take a and I would have to do m minus n. So the rule is that I subtract the exponents. It's very, very important to remember that the bases must match. So see here, the a's match. So in order for that to work, the bases have to match. So I look at this example, I check that the bases match, they do. So then I can do 5 minus 3 and I get x squared. Over here, the bases match. So rather than taking 5 to the 7th and then 5 to the 4th and dividing those, I can use exponent rules to make it faster. So 7 minus 4 is 3, and then I just take 5 times 5 times 5, and I get 125. Okay, next, the powers of a quotient. So that sounds kind of confusing, but it's just you have a quotient, and you raise it to a power. So for example, a over b squared. So notice here I can have 2 different bases, that's fine, but the point is that this exponent out here applies to everything inside. So it becomes a squared b squared. If I had x over y cubed, it becomes x cubed, y cubed. If I had a number, like a fraction, 3 over 5, so we know that 3 over 5 could be a quotient, and I square that, it becomes 3 squared over 5 squared, and therefore I have 9 over 25 as my final answer. Okay, so again, the rule for that one is apply the exponent to the numerator and the denominator. So if you have the bases match, and you have a quotient of a power, you can actually subtract them. If you have an exponent outside of a quotient, the exponent applies to both the numerator and the denominator. Okay, so our next rules for 5 and 6, they apply to multiplication. So rule number 5, the product of powers. Okay, so our rule is that we can add the exponents of like terms. So if the bases match, we can add their exponents. So for example, a to the n times a to the m, we can actually go ahead and add those exponents. So it would be a to the n plus m. If you look at that in terms of numbers, 2 squared times 2 to the 4th would be 2 to the 6th because I go ahead and add those. And then I can simplify it more. 2 to the 6th is 64. Again, in algebraic terms, a to the 3rd times a to the 5th, I add them and I get a to the 8th. Okay, rule number 6, power of a product. So with the power of a product, I have xy raised to the 2nd power. So I have a product inside of here, and I'm raising that product to a power, in this case 2. So therefore, the number outside, the exponent, needs to apply to everything inside. So it becomes x squared y squared. If I had 3a squared, that squared needs to apply to everything inside. So it becomes 3 squared a squared, and therefore 9a squared. This is a very common mistake that students make. They see the 2 out here and they only apply it to the variable, and they forget that it applies also to the coefficient. And they would give me an answer of 3a squared rather than 9a squared. So don't forget that. So again, the rule is that the exponent applies to each part of the product, not just whatever's closest to it. It has to apply to everything inside of there. All right, so if you remember, the last rule is a power of a power. Okay, so a power of a power. You have something raised to a power, and that is then raised to another power. So for example, if you have a to the n raised to the m, that makes it a to the n times n. In an example here, a to the 5th raised to the 4th is a to the 20th. I multiply 5 times 4. Here, 5 squared raised to the 3rd power would be 5 to the 6th. And if I actually multiply that out, I get 15,625. Okay, so again, the rule is with a power of a power, I multiply the exponents and I will get my answer. Okay, lastly, let's revisit this problem from the beginning, this scary, scary problem. So if you remember, this was the problem we started with at the very beginning. So let's apply it. We start this problem. Okay, so let's go one step at a time. The first step, we're going to have to take this exponent and we apply it to everything inside. So we could think about this like the quotient rule. It applies to both the top and the bottom. And we could also think about it like the power of a power. So not only does it apply to everything in here, since the things inside are raised to a power, we can multiply them. So we multiply the 4 by each of these exponents, and we get x to the negative 16th, z to the negative 4th, y to the 12th, z to the negative 4th. We also apply it to the denominator. If we have just an x, that means it's to the 1st power, so x to the 4th, z to the 4th, y to the negative 4th. So what we did first, we applied the 4 to each term using the power of a power rule, and we also remembered that as a quotient, it has to be applied to the numerator and the denominator. Then we went down here to our second step. Combine the 2 terms in the numerator, okay? So combine anything that can be combined. So up here, I had these 2 z's, and they were matching bases, so I could combine them. I combined them together to make z to the 8th. Nothing else was the same, so I left my x to the negative 16th, y to the 12th. At the denominator, I didn't have anything I can combine. So I just combined the 2 terms I could, which were the z's, because they had the same base. All right. Then I move on to 3. So step 3 here, I'm going to take care of the negative exponent. So if you remember, negative exponents, we said we turn them into the reciprocals. So that means any negative exponents that were in the numerator, I need to turn them to 1 over that number. So in other words, they move to the denominator. So the x to the 16th moved to the denominator. The y to the 12th was positive, so it stayed up at the top. The z to the negative 8th, I dropped it down to the denominator. Now, numbers that were already in the denominator, I would move them up to the numerator. So y to the negative 4th would become up at the top. Y to the 4th, because this would be 1 over y to the negative 4th, so it moves up to the top. So I move the y up there, and the x to the 4th and z to the 4th, you'll see them, they're still there. Okay, so to recap, in that step, everything that had a negative exponent, I moved it to the other part of the fraction so that it became its reciprocal. These moved down here, and this moved up here. So my final step is I'm going to go back and I'm going to combine any terms that I have. Okay, so I see that I have two y's up here, so the rule is if these are multiplied together, I can actually add them. So I got y to the 16th. On the bottom, I combine my two x's, so I got x to the 20th. And then my z's I combine, and I got z to the 12th. So I went through and I took this big, huge, scary problem and I just used my 7 rules and applied them one at a time until I was able to solve it. So remember, you won't use every rule in every problem. For example, there was no 0 exponent, so I never had to use that. Okay, but you use as many rules as you need to, one step at a time, and you too can solve problems as difficult as this.